In this video we have some practice problems. I want to find the derivative of these expressions here. So the first one here, we have an exponential. Let me just write the derivative dx. The derivative of an exponential, in this case the exponential e, is the exponential. It would be e to the 2 x to the third plus 3x. And then here we have to apply the chain rule and compute the derivative of the exponent. I'll put it out in front here. Derivative of 2x to the third is 6x. The derivative of 3x is 3, so it's be plus 3 here. And this is a square here. As we got a 3 here. So 3 times 2 is 6, subtract 1. So 6x squared plus 3 times the exponential. No constant of integration because we're doing derivatives. Number 2, we have we'll take the derivative of ln of x to the 5th. With the derivative respect to x here, this expression here. Now we could take the derivative the way it is there, or we could apply property of logs, say this is the same thing. I still have the derivative symbol because I'm not taking the derivative yet. I'm going to rewrite this. Property of logs allows me to bring this exponent as a coefficient, so this would be 5 ln of x. And the 5 is constant, so just like with integrals, I could bring this to the outside and put it in front of the derivative, and then just take the derivative of ln of x. The derivative of ln of x is 1 over x, and then times 5. Gives me 5 over x. Now, if I didn't want to apply that property, I could leave it the way it is, and take the derivative of ln of x to the 5th, and that would just be x to the 5th would be the denominator, and in the numerator I would have the derivative of x to the 5th, which would be 5 x to the 4th, and then it would reduce that, and it still comes out to that answer right there. And number 3, again, it's the derivative with respect to x of this expression. So this one I could rewrite it. It's a natural log here. Properties of logs allows me to bring this out in front. So this would be 1/2 ln, because square root of x is x to the 1/2. So this would be the same thing. Write it this way. Or again, I could bring the 1/2, since it's constant, I could put it out in front of the derivative. Or I can just say the derivative of ln of x is 1 over x, and then times the 1/2. Answer then would be 1 over 2x. For this one here, number 4, again the derivative with respect to x. I have the natural log of a product, so this again is considered like that. So I could rewrite it. Say it's the derivative again, respect to x. Before I take the derivative again, I'm going to break this up using property of logs. Derivative of a product is a sum of the logs, so this would be written this way. Now I can take the derivative term by term. Natural log of 5, that's just a constant. So the derivative of that is 0. And the derivative of ln of absolute x, we have a formula for that. That's 1 over x. That's your answer for that one. For number 5, we have a product. So I use the product rule for derivatives. tells me if you have a product of two functions of x, the derivative will be the first function, whatever it is, we put it down, times the derivative of the second. The derivative of ln of x is 1 over x. So we get that. And then it's plus the second function, which is ln of x, and then it's times the derivative of the first. Derivative of x is 1, so this will be just a 1 here. And then we just simplify. X times 1 over x is 1 plus, and 1 times ln of x is ln of x. That's your answer for that one. Now for number 6, we have the derivative of ln of x to the fourth plus x squared plus 1. So the formula for this tells us that to compute this derivative, whatever this is goes in the denominator. So that's x to the fourth plus x squared plus 1. And in the numerator, you compute the derivative of that expression. So derivative of x to the fourth, 4x to the third. And for the x squared, derivative is 2x. And the derivative of constant 1 is 0. So we get 4x to the third plus 2x over x to the fourth plus x squared plus 1. That's the solution for number 6. For number 7, I'm going to find the derivative of a trig function, sine. So first we take the derivative of sine. That's going to be cosine. Keep the same argument. And then this is multiplied using the chain rule here. This is multiplied by the derivative of the x to the third. I'll put it in front. Just 3x squared. That's the answer for that one. And for the last one here, we have want to find the derivative of this thing with respect to x. It's tangent. Now you have to be careful here. If this were a variable x, then the derivative of tangent would be secant squared. And then we handle the expression here. But e is a constant, pi is a constant. So here we're just taking the derivative of a constant. This is going to be 0. Thanks for watching. We'll see you next time.